Have you ever found yourself puzzled by a piece of code that just doesn't seem to work as expected? If you're dealing with moved from objects in C++, you're not alone. Today, we're diving into a tricky question about the behavior of moved from objects in a vector. I totally get it. The world of C++ can be confusing, especially when it comes to move semantics. Many developers have faced similar challenges, and it can feel like you're walking a tightrope between defined behavior and undefined behavior. Here's the specific question we're tackling today. One user asked, does the rotate left function have defined behavior when one of the elements in the vector is in a moved from state? This is a great question and one that many C++ developers wonder about. To understand this, we need to look at what happens when we move from an object. When you move from an object, it enters a moved from state, which can lead to some unexpected behavior if not handled correctly. Let's break this down. And stick around. By the end of this video, you'll have a clearer understanding of move semantics and how to avoid pitfalls in your code. To address the user's question about the behavior of the rotate left function, we first need to clarify what happens when an object is moved from. In C++, moving from an object leaves it in a valid but unspecified state. Next, when the user moves from the second element of the vector, that element is now in a moved from state. The rotate left function then attempts to move from this moved from object again. The key point here is that the C++ standard does not define the behavior of moving from a moved from object. However, for standard library types like std_string, this operation is generally safe. For user-defined types, the behavior depends on how the move constructor and assignment operator are implemented. If they are implemented correctly, moving from a moved from object should not cause issues. Finally, the user can refer to the C++ standard or specific library documentation for more details. If they encounter a specific case where this behavior is problematic, they should consider revising their type's move semantics. Fun fact, did you know that the concept of move semantics was introduced in C++11? It was a game changer for performance, allowing developers to write more efficient code without unnecessary copies. Now let's look at the answers provided by other users. The user clarifies that your program's behavior is well-defined but unspecified. This means that while the state of the vector is valid, you won't know its exact state without further inspection. They reference the C++ standard, which states that move from objects are not poison and can be safely used, even if their values are unspecified. They also explain that standard library types do not have preconditions for move assignment, meaning you can use them regardless of their state. This applies to user-defined types as well, as long as they meet the library's requirements. Here's a pro tip. Always test your code with various scenarios, especially when dealing with move semantics. This will help you catch any potential issues early on. And there you have it. Understanding moved from objects can save you from headaches down the line. If you found this video helpful, don't forget to subscribe for more coding tips and tricks. Happy coding!